What's up, everybody? How's it going?
I'm doing good. You?
Good. Matt, how are you?
Doing well. Yeah.
Great. Cool. So welcome to another edition of Let's Talk Data Engineering. Today, we want to talk about two different topics, DataOps and optimizers. I don't think we'll talk about data optimizers, but maybe we will. I don't know. We'll find a way. I'm shoehorning that in. Dad joke. Cool. What's been on your mind lately, Chris?
Well, I finally made it back to the UK, so that was an achievement. So I think last time we spoke, I was still my nomadic tour of Europe. So I got back a couple of weeks ago. So that was one achievement. It took me a while to get back. And the other one, I think, so we've obviously hot topic at the moment is data ops, XOps. So it was we can have a good chat about that, and something that's and the optimize, something I've been living with this week, and just think it's a bit of a dying art. So we can cover
For
that.
people that don't know what you mean by optimizer, what do you mean by optimizer? Like query optimizers, or
Query optimizer. So I mean, depending on the audience out there. So any of those ex-Oracle, people, it's the explain plan. It's that path your query is taking. It's the table scans. It's the indexes, if they are using indexes in Oracle one, how they're using them to get you the best result and get you the best time of that query. So so I think that's the role of the optimizer is to find the most efficient way of your SQL or your query running. Mm-hmm. Which I think a lot of people just think if it's not running fast, just throw a bigger box at it, which they have been able to in this world of cloud engine, the world of cloud that we live in now. But I think from probably because of my history and that, it's just you don't always have to throw more power at it. I think just understanding what's going on there, and I mean back to data modeling conversation we talked in the past. A good well-designed data model for your data pipeline, whatever stage of that pipeline it is. So, I mean, the optimum. Everyone always focuses on maybe the end part of the query, how that star schema is performing, or how your Tableau queries are executing on it. But it's that whole pipeline that can be optimized. So it's that ingest part, it's your transformation part. So, I think just understanding what's going on under the bonnet is something that not everyone does now, because it's been hidden from us. The likes of Snowflake or BigQuery or Redshift, you didn't need to do as much, especially with Snowflake. No index is required. I'm not as. I mean, I don't know if you see the same thing with BigQuery. That's not something I work closely with. So, do you see a similar thing in that area?
I mean, BigQuery, there are no indexes, but you can optimize by partitioning. To be quite frank, the BigQuery, I love BigQuery the product, but like their optimizer is not as good as Snowflake's optimizer. Like they don't do a lot of things with predicate reordering, for example, that Snowflake automates. And so optimization of BigQuery is actually even more important. And the other comment I was going to make is, how many times have we seen people where a large query is running slowly, so they'll crank up just a huge Snowflake data warehouse and spend like $2,000 in a day, and it's not faster because either the query is just not optimized at all, or the bottleneck is somewhere else in the system.
Right.
I've been on teams that have done this, and there were some unhappy people when this happened.
Or they accidentally forgot a join part of their join query, and they're doing a Cartesian cross-product join, which on a couple of billion row tables may not give you the result you want.
Well, and also one of the problems we ran into with Snowflake is that if you make some assumptions about uniqueness of keys and the keys are not unique, then certain types of queries will basically just hang and run. Yeah, you get weird artifacts, and they can just run for hours.
I guess. What are some best practices then with using the query optimizer and making sure you're writing performant code?
So I'm going to be quite focused on Snowflake, because I mean that's where I see most of this is. It's understanding, for example, if you've got predicates, you've got things in your where clause. If you're doing calculations on them, it's not going to use the metadata that's associated to find out where those micro partitions are. So you're going to be doing full table scans. You may be doing merge queries or delete queries on these things. They're going to collide because they're not going to know which query is the golden one, and the whole point of is protecting your data. So it's not going to decide which query is going to be the king. So you're going to get either batch failures or it's going to run a lot. It's going to cost you a lot more to run your batch when it doesn't need to. So a good bit of design. And I think it probably leads back into that DataOps piece. Actually, is I do believe that part of your route to live. So, mate, you've got your DataOps pipeline. It's running. Before you go there, on the pull request, look at the query. Maybe on that you actually have the query plan. It's showing. So the person who's going to go, yeah, that's fine. They may know more than the other person writing it. And they can advise, yeah, that will be performant going forward. It's a nice gateway check before they go to run on maybe production volumes of data and they think, oh, I'm just going to stick a XXL on it because it must be the volume that's caused the issue when it's probably just a bad written query.
Actually, on that note too, it was Andrew Mason. He writes, do you think the fact that we can turn the cloud boxes to 11 has reduced the art of data modeling?
Totally. Developers have got lazy, and they probably don't even check the query profile if it's actually doing the most optimized or most performant path. So I think it's that negative effect of that unlimited compute. With unlimited compute comes unlimited costs. So if you're quite happy to keep paying those unlimited costs, don't bother tuning your queries. But you're going to get to the stage where someone's going to question those costs. I mean, we talked about this recently about the next big thing is going to be cost optimization, not query cost optimization, monetary cost optimization. What is actually costing your OpEx budget? So
yeah. I think the art of data modeling, it's an interesting topic as well, because I think part of it is definitely the fact that you can throw unlimited resources at data and get, I guess, just kind of beat the results out of the data with enough firepower, right? But I think it also, the art of data modeling is, I would say it's changing in some ways because of the, denormalization and just different design patterns for the data itself. And I think I see modern analytical engineers who actually don't know that much about Kimball, which is kind of surprising. Maybe that's a good thing. Maybe it's not. Because I guess my point is things evolve, right? And so when we talk about data modeling, maybe it also means that practices will evolve. But I think at the end of the day, you still need to deliver models. I'm talking about data models that make sense to the end users, right? So.
Yeah, and I think one of the problems now is that we need a new generation of data modeling paradigms. I mean, so you read, a few years ago, you used to read, Google's official trainings for BigQuery, and it just basically would tell you, oh, denormalize everything. And it's like, well, what does that even mean? How does one denormalize, flatten everything? That's not even practical. And I think in the Hadoop era, there was just the tendency to completely dismiss the notion of data modeling. And now we need something that kind of resembles like a relaxed Kimball. In other words, yes, we're going to have facts and dimensions, but we're also going to use wider tables, and we're going to take advantage of arrays and other things. And like someone needs to write that book, right? Like someone needs to write the definitive book for data modeling in columnar data systems that brings forward the older practices of data modeling, the really good pieces, but also talks about how to make them flexible to improve performance.
Yeah, I think we touched last show a couple of weeks ago. Robert Wandsworth, I think, who talked about Data Vault. I've actually since caught up with him. I don't know if he's online at the moment, but it's that pragmatic approach to data modeling as well. Is that knowing what is the right pattern, what is the right approach for the right use case. So we talk about facts, dimensions, that's going to suit a Tableau, a ThoughtSpot, a Power BI style of reporting tool. But maybe you want to actually feed some machine learning algorithm that does need 1,000 different columns on there to work out which are the ones, or to vary that to get you the best Gini score, or the best result for that particular algorithm. And so that would be a different approach. It's knowing what pattern is right for the right time, but also being pragmatic. You don't always have to go with Kimball. You don't always have to go Data Vault, or you don't always have to go wide. Knowing when is the right choice, and that's the art, and that's the dying skill. I think that we need to probably help educate the people out there.
I mean, speaking of Robert Wadsworth, hello. Yeah, he says putting costs to one side, there's also the environmental impact. If every engineer found a 10% gain today, the impact on global energy consumption would be insane. I agree. It's not quite Bitcoin mining, but give us time. We like a good challenge. What do you guys think?
I think SQL-based blockchain Bitcoin miners are the future, Joe. You came up with it right here. We now own all that IP. So.
Wow.
I mean, it's true though. Sometimes you'll see a 10 times gain, right? I'm sure you've seen stuff like this, Chris, where partitioning or filtering appropriately can create a huge gain in performance. Yeah, and there's an environmental impact.
And I think it's I've seen this before. Is that the art of the delta date, the art of just processing new data that's come in. If it's not done well, and I've seen this before, where they've got maybe 4 dependencies thing, let's do a full refresh every night, and yeah, you can get away with that year 1, maybe get away with that year 2. After that, I mean, someone's going to ask, why is your cost is going up that much when your volume's only up this much? There's no correlation, and that's because of bad design. So yeah, I think that's a good quest, Robert. I mean, we should all do our bit for the environment, but I think we should shoot higher than 10%. I reckon we could get at least 25% efficiency on these things.
In America, we'll at least double whatever you try and do. So don't worry about it.
Of course, yeah.
Yeah, we go big around here. So
go big or go home.
Yeah, Martin, what's up, man? Training models and GPUs is horribly wasteful, sure, but running models has barely any impact comparatively. Yeah, I mean, we're joking, I think. But yeah, I mean, it is interesting. I've seen some studies where they assess the impact of the cloud on carbon emissions, and it's depending on what you read, it is non-trivial, and it's something to be aware of. But anyway, I kind of bring it back to query optimizers and stuff, and writing. I just think maybe the art of writing good queries is sort of diminished as well. Like literally before this, I was actually looking at a query that somebody had written, and it was I needed to find gauze bandages because my eyes were starting to drip blood from reading this thing. They weren't using any CTEs. It was left joins in about 18 or 19 tables. Everything about it was just pure craziness. And so I would say the query optimizer is definitely one thing. Use explain plans, but also just learn to write better code in general. That doesn't hurt anybody. And I would say the number of people you hurt from writing bad code, either them having to read it or the impact of it running slow, is it can't be understated.
I agree. It's a maintainability piece, isn't it? So, and I've seen this before. Is someone goes and gets a query that's been generated by some tool. They think, oh, that's nearly it. Oh, I'm going to amend it myself. They go and take it, and they're going to hack around with some code. They probably don't know what it did in the first place. And I mean, Tableau doesn't write the most efficient SQL anyway.
Looker generates.
Yeah, and it is nasty, and it's undocumented as well. So I think that having that stepping back, understanding what you're trying to achieve, and a well-documented understanding, whether joins, not using left-out joins unless you really need them. Would it have missing values? Are you putting it in just for the sake of it? Are you doing it to get around bad data quality? Understanding why you're having to do these things is another thing to helping you write a good query.
And then there's, again, the data modeling piece. I mean, building better data pipelines, pre-transforming data, pre-aggregating data, pre-joining data, that's all part of the data modeling problem, especially when you find that you have the same set of queries that's doing 18 joins every day, because your analysts are going to consume exactly that join of 18 tables. Like, why not pre-process that so you do that work once instead of 100 times? Yeah,
because my question was, well, okay, that's great on small amounts of data. What happens when it grows?
Yep.
Over time, right? Like you're kind of stuck. And this thing was expected to run sort of in isolation on a device client, actually. So once it's out in the wild and it's accumulating data, you kind of see what happens, right? It's out of your control. Yeah. So, so I think to your point, like write good code. And also, I think to bring it back to what you're saying, Chris, with DataOps, this is actually a really underrated piece of DataOps too, which is writing performant code to begin with. I think that especially in data, and I think in technology, it's one thing where you'll catch it because of testing. Like your app is running slow. Well, we can fix that. Data is a bit different. I mean, how often have we said, well, I mean, that query is just supposed to run slow, right? That's just expected behavior. So
maybe for the person that said it, because they've never written some good code in the past. So maybe that's why.
There's something to that. Yeah.
Yeah.
I mean, the other thing is, there's a fundamental organizational problem here, right? How do you tell a data engineering team that's overtaxed, that like constantly has new deliverables thrown at them, new tickets, like, hey, you guys should slow down and work on actually modeling the data, on understanding your performance problems and training people on better query practices. Like from a data ops perspective, how do you organize that?
Yeah, there's two carrots to beat. There's one, you make sure that department's being recharged the associated costs they don't, and then I've seen it, and then educating maybe someone that's the purse holder of that is that, by the way, if you made these changes, you're going to save X amount of money. You'll soon see that task will go on their backlog quite quick because the business stakeholders said, hold on, I've seen the running costs. I know you can do this more efficiently. Let's do that to save the business money. And at the end of the day, if you're building data products for your clients, you're putting a margin on it. If you can make more of a margin on it because you've written it more effectively, it makes more business sense. So yeah.
What are some ways that you would allocate costs, though? I mean, I think Matt and I have some ideas, but for people who don't know about these dark arts of attributing costs, what are some ways?
So, and I will go with the Snowflake one because it is the easiest one to do that recharging model anyway, and others may have some nuances and other ways of doing it, but it's having that virtual warehouses that are specifically for either a business unit or specifically for a purpose or a sub part of that business unit. So you can. There's always going to be some shared pieces. There's some pieces that you're not going to be able to, and maybe that's a shared cost for everyone that's on the platform, and it's proportionalized based on either the number of queries they run, number of credits they've used generally, or maybe the storage of their own data they've got. So there's the compute thing that you can actually allocate back to them. I think having some dashboard or having that being able to report it back to that community that looks at it and actually evidencing the cost of these things. Another thing so that's monitoring the cost, but to raise the profile of those initial costs, having a dashboard at top 10 most costing queries, ones with the largest number of disk spillage, or there's lots of metrics you can collect, which become these are areas of possible optimization. So yeah, one is allocating who's actually doing it, and then one is providing the details for how they could improve what's there. I think if you get that out there, then that ownership of that cost thing, it's managed, and because you've been able to give them the information for them to self-serve and be better data engineers or data departments or building better data apps.
Right, makes a lot of sense. Another thing you can do too is tag your resources. So if you're in a cloud, set under your top level organization, set up accounts, and under those tag your resources so you can finally get fine-grained attribution, at least as fine-grained as you can. Yeah, I think all this is good. I like the leaderboard of least performing queries. Maybe give somebody a prize at the end of the week or for the worst query of the week or something. We actually used to do this at an old employer of mine. If you made a big mistake, you got like this really ugly thing you get to stick on your desk for the week. And so then we'd pass that around every week for the biggest screw ups. But I'm not a fan of at the same time, I'm not a fan of really motivating by making people feel outed. So.
Yeah, it's not a name and shaming thing, and it's more of that giving the advice. So I wouldn't go and put the top offending usernames up there, but just because if someone's interested, they're going to find out anyway. But you don't have to point out there.
Gosh, Chris is consistently winning the leaderboard here for the past several weeks. It's great. Yeah, it was Marin. He says the trouble comes when you have to explain pretty intangible benefits of optimization to businesses. Then it's less about benefits and more about risks. What do you guys think about this comment? And there's a follow-up comment I want to get to after this.
I think it's that trade-off thing, because the business is going to want the data. So maybe that poor performing query at the point of making sure that business were able to get that data and get the value they need out of it. You can live with it, but it's just that technical debt piece as well. Is that all right? No, I've done it. I've cut some corners to go and get it out there. They've got it out there. Let's just make sure you go back and tune it afterwards. So it's just not, don't just wash your hands of it and go, right, done. I've satisfied that business requirement. Let's go to the next one. Yeah, you know it meant we don't optimize. Go back and just add that little bit of optimization later, because next time you go and run it with optimization, you'll know how to do it better. So the next time you won't need as much optimization. But if you never optimize, you're never going to know how to optimize.
What do you think, Matt?
Yeah, I mean, I think where the leaderboard idea is actually really useful is if you do have a centralized data engineering team, they can say, hey, these queries are running slow. Or another big thing that comes up is you have, the same queries run 50 times every day on the same data. Seen that again and again. And ideally, they can do some more centralized optimization, or at least communicate the benefits out to those teams. Because analysts don't have time to worry about this stuff. Typically, unless their query is really slow, they're not going to worry about it. They'll just consume a bunch of resources to get it done, or they'll run the queries separately, repeatedly. And as data engineers, you can do things like say, well, maybe we should just create a table for this result once a day. Everyone consumes from that table, so we're not all running this massive data scan, or hey, this one query is querying a petabyte when it could be querying like 10 gigabytes.
Well, this is one of the tenets of ops too,
yeah.
whether you're talking dev or data ops, right, or whatever. It's just observability and monitoring, right, and getting feedback on how things are performing. So I would say, monitoring is great actually, and this kind of brings us back to DevOps in general and data ops, which is, the tenets are automation, observability and monitoring, and then incident response, right? So we're talking about data ops. Definitely monitor things. That means having them on a monitor. Dev teams do this all the time using Grafana, right? App uptime and so forth, right? You have an SLA probably with either your customers or internally, and internal data teams I think should have an SLA saying query response is going to be here. Maybe have a control chart, which is upper lower bound of acceptability within range. And if it's if queries are performant, great. If you start seeing spikes in lag, then you need to address things. It may be a query optimizer, maybe need to rewrite because of a query plan. It might be hardware issues. In Chris's case, Chris loves to throw 6XLs and everything, so we'll just do that. It might be any number of things. It might be I/O on your network, or disk or whatever. There's a lot of things you need to look at, but this is where observability comes in. I would say that the worst place you want to be is when you find out from stakeholders that I'm not getting my data, or it's late, right? And it wasn't always this way. And you're like, well, I don't know. It must be you, obviously. We're fine. So, Guy Thompson has a comment here. Unfortunately, lots of companies are fine with quick and dirty, or don't fix something that isn't broken. Going back to refactor for optimization is sometimes difficult to explain as a value add to non-practitioners. Thoughts on that related comment?
Yes, because something's difficult doesn't mean you shouldn't do it. It is sometimes challenging, but I think to tackle those difficult things is evidencing it. So if something's running for a while and you have that good monitoring, that good we can call that DataOps pipeline. So if you're collecting stats as it's going all the way through it, you can start correlating, performance of data volumes. So as soon as you see the volumes going up and performance going the other way, you go, right, I need to deal with that because this problem's going to get worse. The gap's getting any worse. The more volume going, the less performance it's going to get. So I tell you, I know a lot of companies that go that quick and dirty route, but I think this is the role of the lead data engineer, the lead architect, the data product owner, whoever's running that. This is your environment, your roadmap. You just help address these things and help with that education piece. Every 6 sprints you got, have a hardening sprint, have a sprint where you just focus on getting this stuff done. Because if you don't, you're going to move slower and slower. You move slower and slower, other companies are going to take over from you because you've got too much friction. You can't get things into live. When you do, you've got mistakes because you're in environments that you don't know whether they're that I think that we talked about earlier, drift, environment drift, data drift. Yeah, the more you do quick and dirty, the more drift you're going to insert into your environment. So more drift, more friction, less value.
Bingo.
Yeah.
I think. Oh, sorry, Matt. Go ahead.
Oh, I was going to say, I mean, Chris, you kind of alluded earlier to this notion of cost engineering more broadly in the cloud. And that is, I'm not signing a contract up front to just buy hardware, park it in my data center, and then that's it. You know, I make monthly payments or something. Every month, the cloud spend can vary dramatically, driven partially by the efficiency of your queries. And so, you know, you can spend millions of dollars a year as a large organization just on queries. How do we like incentivize cost engineering for teams? What's an appropriate way to like compensate them if they're doing cost engineering work where they could potentially cut cloud spend by 50% in some areas? I mean, we see terribly inefficient cloud spend all the time.
Yeah, but what's a culture that presents that though, or provides that? I think it comes back to this quick and dirty sort of culture. If that's acceptable, I would say, like your engineering, you mentioned, Chris, like companies are going to get ahead of you. I would also say at some point you're going to move so slow that like your team's going to be replaced.
Oh, yeah.
Right. Yeah. So I don't think, quick and dirty, I think is a good, it works in the short term, but as anybody knows, it's not just in tech, but it's in general, like you can't hide mistakes forever. Like you have to have the discipline and fix them. And frankly, it comes down to the leadership, but I'd say it also comes down to incentives like Matt's pointing out. So this should just be part of like compensation really is like, well, but part of it is just your job, honestly, is just to like, take care of this stuff.
Yeah, so self-pride in what you do. I mean,
right. Yeah, it's self-pride. You're a craftsman, a craftswoman.
Yeah.
It's like, this is.
Yeah, so someone's a carpenter. They're not going to go and give you a nice new table without it nice and polished and sanded well. In the same way with you're doing your data pipeline. You want that to be most efficient, metadata driven, supportable piece of code, and you can be proud of it. Otherwise, you've got to leave because they're going to find out that you're rubbish.
Rubbish for sure. Like, can you imagine if you're a car manufacturer? This actually happened in the U.S. back in the day. Like, they put in like engines backwards and stuff, or cars being complete, and they just ship them out because it's like, well, nobody cares, right? And they only, this was a common theme back in the 60s and 70s with American car manufacturers, and so, and they want to do the quick and dirty route because they're not incentivized to do anything other than that, right? It's like, I don't care. I just need to pump out X number of cars per day, right? It's sort of like lines of code. It's like, I don't care if it's good or not. It's as long as I, keep my job, my pension. I really don't care what happens. Get into a car wreck and the car doesn't work. That's your problem, not mine. Like, that's literally the attitude. And that's a quick and dirty mindset. It drives me insane. I'm sure it drives you guys insane. But and I would say, for people out there who do quick and dirty, like, you can keep up that practice. I think, your longevity in this market right now, in this field, is short. I wouldn't hire you. I don't think Chris would. Matt wouldn't. So nobody else would either. So your reputation is everything.
Yep. You're only as good as your last job.
Exactly.
Yep.
Mike Nash, what up? Thank you from your neck of the woods, sir, Chris.
Yeah.
Happy Friday. Following optimization, do you find that sometimes data is poorly captured and needs refining, re-engineering from beginning before throwing hardware or sweat at it? How often does this happen, and how do you approach a client with this? Have at it, guys.
Well, I think how often? All the time. How do you approach it? It's back to that evidencing it thing again. Is like people don't know their data's bad until you show them it's bad. So yeah, I mean that go back to the data modeling thing. So as part of your modeling of your raw, your curated, or whatever layers you call it coming in, you should put some of that standard cleansing, refactoring of that data that comes in. But there's something, again, I get annoyed a lot nowadays, but something really annoys me is that it's always the data analytics team that it's their fault that the data is poor quality, even though the data has actually been captured in the source systems, in the OLTP systems, because they've got bad website forms, they've got bad referential integrity on their database, they've got no checking for non-nulls, no prime, whatever bad design at the beginning of the collection of that data. Downstream just feels it. So we as a data practitioner, I've seen too much. We try and fix it ourselves, and I think what we should really be doing is evidencing that poor quality and getting that fixed close to, I call it data quality firewall, as close to the inception of that data or ingestion of that data as possible in the source systems, not the data warehouse. But yeah, Mike, we do need to have our catch up. I know I keep threatening, but yeah, you're right. You need to good model data will be easier to optimize. Have that data quality firewall as far back as you can before it even gets to the warehouse where possible, or warehouse data lake, whatever term you use.
Yeah, we see this all the time. And to your point, Chris, like one of the things we talk with clients about a lot is like, if you really should be a data focused company now, and that's not just generating data in your application. It means that from the get-go, if you're conceiving of some new product, you should be thinking about the analytics that are going to consume that data downstream. And that means that it really needs to move away from the traditional throw it over the wall model of data to shared responsibility. That is, the software developers who are developing in the front end, the back end, everything about the app need to think about how that data is going to be consumed downstream. And obviously they're not analysts, they're not data engineers or data scientists, but they can communicate with the teams that are going to consume it from the get-go. And you don't want death by committee, right? But you at least want some notion of responsibility, like, hey, I'm trying to make my data more valuable for the consumers downstream with less work and less friction, so that my app actually gets better and more powerful through that process.
Actually, having breakfast with a friend of mine today. He was telling me that he runs a manufacturing company. He was talking about exactly this problem, actually. So he has a team of analysts. They're trying to get data from this manufacturing software, this planning software, and the data is garbage. Everyone inputs the data wrong into the software. Therefore, it's unusable for analytics. And so the first step he did was like, everyone, I encourage you to please put your data in correctly. Please do. Awesome. A few weeks later, nobody does it. So he's like, I hate to be that guy. I'm going to have to start writing you up. If you don't put it in correctly over a bit of time, you're out. Nobody did it. It got slightly better, but people still mess it up. And so finally he had his analyst. The analyst was like, I'm just going to talk to these people every day. I'm going to go down to their factory, and we're just going to have a talk. I'm going to make sure the numbers match. That fixed it. So threats didn't work. Being nice didn't work, but having communication between the stakeholder and the people entering the data, that works. So yeah, that's literally like this throwing sweat at it. Like, yeah, that's a lot of just manual intervention. But if you want good data, that's an extreme example, but that's something I literally just heard about this morning and it worked. So
yeah, I think it's making those people that are actually putting it in understanding the value of what they're doing. So that you put that in there, we're going to make more money. This is going to happen. Yeah. So and I think that's the biggest. You can't beat people with a stick. This doesn't work. Threatening them doesn't work as well. But just relating to them, saying that this is the benefits that we're going to get. If you help me, I can. That problem you've got. That other thing, we can help you with that as well. And that community thing I like to talk about as well is that you're all in this together. You're all one company. Let's see how you can work together and just find how you can help each other.
That's exactly it. And it's so underrated. I think we all want to throw technical solutions at problems, but half the time I found or more issues can be solved just by going and talking to people. Like, get out of your chair. That's not really a thing these days. Nobody's in an office, but call somebody on the phone and just talk and figure things out. Like, I think that I've always had the most success. And I actually have a rule, like Matt knows, if a conversation is confusing and it's more than 5 lines in Slack or something, and we still haven't figured it out and it's confusing to everybody, I just give you a call and we sort it out. Right.
Well, think about this. I mean, I think all of us have to do sales to some extent, right? We all have to go talk to clients or prospective clients like, hey, we think you should do this project. We've talked about it together. Here's what it's going to look like. Think about trying to do all your sales just through tickets or through emails or something without actually talking.
Oh, Lord. Yeah.
In some sense, when you're talking to engineers about their data, you're selling hey, you should really do this. We want you to commit to doing this so that we can all produce more value together, and talking to them makes a huge difference.
Exactly. Got a question from Kevin. What are your thoughts on cloud products that offer unlimited compute and query capability for a fixed cost based on data size? Would this make cost management a lot easier?
Yeah, who's doing that?
I think he's talking about I think Yellow Brick or something like that.
Oh, okay.
Yeah.
Yeah. Well, that's probably because they're funded at the moment. And they can make a lot.
Yeah.
Later on, they're going to have to get real with that, because you can't live unlimited compute and unlimited query capacity without and fix the price. It's just not possible.
Well, it's
But
like
anyway.
It's like the old thing back when, in the 50s, like the US was developing nuclear power, and they said, oh, it's going to be too cheap to meter. Well, first of all, that didn't happen. And second, if you don't have incentives around a resource, then people will just waste it like crazy, like you're saying, Chris.
Well, I think, and I can understand maybe the value of this approach. So I think maybe the pros of it is, sure, at a data size, assuming it's static, right? Like that I think that might be attractive. The thing is, though, data sizes are changing often. And so I'm penalized if my data size changes in that regard, right? The more data I accumulate, the more I have to pay. And so I would say it works if your data size is static. I could see that being actually really attractive. But at the flip side, I as a business, I wouldn't expect my data size to remain static. So that's just simple physics. If my data size is static, that means I'm probably static as a business as well.
Yep.
So.
And it brings us back to old incentives, which is the old on-prem incentives. Like don't overbuy a system to store more data because it's going to cost a ton of money, versus the modern cloud data warehousing incentive. Like you can store a ton of data. It's all about how much you're querying it really for costs.
Yeah. What are the questions we have here? Ask DevOps. Good question, Kevin. Ask DevOps asks, when to hire a DataOps engineer, what stage mostly? Also, data engineers feel confused with this role mostly because of mixed responsibilities and possible overlap. Any thoughts on this?
So, yeah, there are overlaps, definitely. And I think it's down to team size, maturity size of it. So if you get to the size now, you've got multiple teams, multiple squads that work on these things with mixed capabilities. Then you're going to need someone with that DataOps focus. And if it is, they're going to be everyone's friend because they're going to sorting everything else, and the data engineers get on their bit, and the DataOps people get on theirs. If you want to be that, do everything, and feel confused about that role, work in a company where you're both, and then you won't need to be confused. And I think naturally people will fall into one or the other. I've seen that as well. You'll become more of a, and we've talked about this with Joe a few times, you're part of the ingest, or you're part of the data modeling part, or you're part of that infrastructure part. So if you can do it all, great. You will never find everyone that can do it all. So naturally, at some point, your team is going to get to the stage where you've got the DataOps, what they perform, the roles they do are going to be quite clear and understood what they do, and then the engineer is just doing the pipelines on top of that infrastructure, that capabilities that the DataOps team DataOps engineer has put that in place.
Makes a lot of sense. I mean, we identify DataOps as one of the undercurrents of data engineering. So I think it's something that undercuts the entire data engineering lifecycle. DataOps is. I mean, you're going to have to automate across the lifecycle. You're going to have to observe and monitor. And you're going to have a plan in case something goes wrong anywhere in the cycle. And so I don't know that you would necessarily escape DataOps as a practice per se. Now, as Chris says, it depends on how big you are, right? If you're a solo data engineer, well, guess what else you get to be doing? It's sort of like if you're a software engineer at a company, you do a lot of the DevOps stuff, CI/CD pipelines and so forth, depending on your maturity. Obviously, I know a lot of companies that say they're doing DevOps and they're still doing kind of intermittent builds or not doing builds and just deploying to an EC2 server. So whatever you want to call it, tomato. But I think at the end of the day, as long as you can reduce defects, and reduce time to value, those are the things that I care about. I don't really care how you do it or what you want to call it. What do you think, Matt?
Yeah, I tend to agree. I mean, I think in practice, the DataOps role can end up being part of data engineering. It really depends on how your organization is set up. Ideally, one way or the other, you do have a plan for adopting a lot of these practices, and you decide if that needs to be a separate engineer or just all of your data engineers participate in the process.
Right. Aaron asks, what's the worst example of data quality you've ever seen? Oh boy, this is going to be fun. We're not going to name names of anybody, but I think we can name examples. Go for it, guys. This should be fun.
I'm trying to think of which one's not going to be that easy for them to work out who it is.
A race to the bottom, right? Like, in other words, we can all try to outcompete each other on this one.
I've seen. I mean, one I think is that monitoring piece. Like when I built my pipeline, it worked, and then later on, it does a lit. And it was basically, it worked fine until they did a change, and then I think nulls were being mapped. So, and they had a filter on only the roles that didn't have nulls in, which meant that they weren't picking up any new data. So they're making a decision on historical data that was never being maintained. So that's one classic.
And how often have we seen this happen? I mean, I've seen it happen many, many times where data just stops being updated and no one notices. Like somehow the reports.
That happens all the time. All the time.
Back to that DataOps piece as well. So part of your DataOps is you should be putting in, or that pipeline should even include that monitoring, that looking at that data drift, having that data quality metrics, looking for changes of cardinality, change of distinct values, change your nulls over time. And then once you collect that data, that metadata, that audit data, you can start using some nice machine learning or some nice algorithms across it. And you can start to look for, well, you'll probably have some false positives, but you can start to remember, hold on, that's not right. Why is my distinct count of customers gone from 4,000 to 4 million? That's not right. And that's because someone's either mapped in the wrong ID or they've done a migration across something. So, it's you always need to monitor your own data. So I think analytics on your pipeline is something that I don't see that often, and it's something that I really try and encourage any of the clients we work with to get that in. It's just part of your foundations piece.
Yeah, but nobody ever teaches this though, right? Like there's not really like an analytics pipeline quality checks for dummies or something, right? So I guess it's maybe a book we should all write at some point.
There's a section of the current book maybe or something.
Yeah. Actually it is. But I mean, these are all just, I think, the worst, I can't say the worst, but I'd say one of the gnarliest, I think culprits and stuff was some data that we saw from an old mainframe from the 80s that would restrict the column lengths to 7 characters.
It's like the column names, right? Like
column names, yeah, all over 7 random characters too. Sort of random, it's not really, but it also wasn't documented, so nobody actually knew what these columns were.
Is that DBT? DB2, sorry.
It's good, gets it.
That was 6 characters, wasn't it?
Was DBT?
Yeah, so, yeah, and it was okay. So, but then it was like, okay, so I don't even know what this column is or what it's supposed to map to or anything, and so that was an interesting one. But that was, I don't want to say it's necessarily a data quality issue as much as it was just I think a communication issue because not much was documented. Now, in terms of data quality, I would say maybe I wouldn't say the worst because I'm not going to point anyone out, but I would say common stuff is obviously really bad parsing. I think we've all seen this. You import from a CSV and then everything's mangled and somehow it still gets in because every column is a string. And so it sort of just escapes scrutiny. That happens, I would say, more often than we'd care. And with that data, you really can't do much about it. I would say another one we're looking at, like somebody had put timestamps as keys in a document database. So that
was a good one.
Yeah, that was a great one. So if you can imagine going through a JSON doc, but all of your keys are timestamps, not values, but the other way around.
Yeah.
Try and think about, just wrap your brain around that one for a second. So that happened.
It was bad. I mean, can you imagine trying to set up indexes on that Mongo table? It was really, really bad.
Yeah. So say stuff like that, but I think that was an interesting one just because. But yeah, I would just say stuff like that. And I think the main stuff I see is just parsing problems more than anything, and bad data input. That's the other one. Like form fields that accept any value. That's always a culprit. Anything with manual entry, you can forget about having. You should just assume your data is going to suck really bad.
Unless you have checks on it, right?
Unless you have checks, right?
Actually checks for the right format. Yeah.
Yeah, for sure.
It's
and then it's still misspellings though. That's going to happen.
Oh, yeah.
So if you don't have master data management, you're still going to have, And so tell me, small companies that use master data management, right?
Either they often they know what master data is, so let alone having a master data management. I mean, to your conversation about the well, DB2, you say, well, it's six characters. I've seen exactly the same thing before, but I suppose that was a limitation of probably when the database was created.
Oh, it totally was. Yeah.
But it's that data dictionary piece as well. So, like, okay, if you had that and someone had gone and put that in to know that those 5 or 6 characters actually meant product or actually meant product line or whatever it was. Some things you can guess, but with 6 separate characters, it's not going to be that easy. Especially sometimes I've seen it when it's written in German, so that's even more. I for a German company as well. So all the abbreviation are actually in German. So first we have to learn another language to find out what the abbreviation may have meant. So that can be a challenge.
Yeah, for sure. I'd say some other culprits too are just encodings. So different encodings can present some data quality problems, I would say, and these are the ones that are hard to catch too, right? Because you can't just see them off the bat. Like use a real text editor to find all the hidden characters and morph characters. That tends to be, I would say, where I've seen some really weird issues that just were not obvious at all on the surface.
Another thing to keep in mind is that a lot of these data quality issues can, first of all, be completely outside the pipelines themselves. So back to what you were saying, Chris, application team changes something in their app and then new data starts arriving. No one notices that it's completely mangling downstream transforms. Another common one is stuff that's completely external from the company. So I've seen cases where someone brings in a testing provider to test a search service, and then all of a sudden you start getting all these random searches injected into your search data that is used for sorting algorithms. No one notices that these are fake searches. Like no one is checking the user agents that would tell you, oh, this is the test provider. This is not our users running these searches. And then you have bots, which are just the bane of so many people's big data engineers' existence.
Well, that's a lot of web traffic too.
A lot of web traffic. Yeah, all that stuff can affect your data quality. And that's where data has entropy, right? Like you just have to monitor it and say, hey, we got a huge spike of bot traffic that's totally going to skew our sort models, for example, but we have to do something about that.
Yep. Cool. Anything else in you guys' mind before we cut out for the lovely weekend?
I think it's, well, yeah, I think we covered data ops and query optimize quite a bit, and we touched on data quality quite a bit as well. So
I think it's a bit there. It's a fun conversation. There's a lot to unpack. I think that data ops space is one where I think there's still a lot of room for maturity. The ops space in general is still a lot of room for maturity, and you couple in ML ops and what I see of the day, data prep ops. That was another one. I think somebody just trademarked that. So there's no shortage of ops these days. Ops is everywhere. So we'll see. But at the same time, I think we were talking earlier, Chris, about how, I don't know about your predictions. Mine is, I think at some point, a lot of these ops, these different distinctions are actually going to go away. So I think as ML and data and software engineering becomes actually more tightly coupled, my prediction is maybe, think about what you're doing. It's all kind of the same stuff. You're monitoring, right? You monitor for slightly different things, but actually not that different.
I think probably the last thought I've got on DataOps, and we didn't quite touch on it earlier, but it's the tooling or products that you use and how DataOps friendly they are. So I'm not picking on tools here, but I'm just going to name some anyway. So Informatica, maybe DataStage or something. They all store their code in a repository. So if you now want to have your DataOps pipeline that's going to send your DDL, your infrastructure piece, now you've got to be able to call up to go and manage your code that's stored in a repository somewhere. You've got to do a pull request on that. No one's even going to know what that code looks like because it's proprietary to that product. So I think the last thing I say is that if you're looking at DataOps strategy, you need to make sure that the tooling you're looking for to build in place is DataOps friendly, because you're never going to succeed if you've got some bits of kit in there that work in maybe an older style way that isn't DataOps friendly.
Yeah, it's funny too. Like all the interesting activity we see in the data startup space right now, there are some exceptions, but for the most part, it's all around these kinds of tools, right? Yep. What I would call data ops tools. And yeah, some of our friends have talked about just the huge frustration of no interoperational standards between all these tools. Like, can we handle metadata in a way where everyone agrees on some kind of standard, and then you can exchange metadata?
Yeah, it's still super early. I mean, I think we're all interested to see where it goes. And probably food for more talks down the road. So
Definitely.
Awesome, man. Well, I think it's good place designing to close out. Chris, as always, great chatting with you. Yeah, hope you have a good time, and we'll talk to you next time. So
Yeah, definitely. All right.
Okay. All right. And thanks to the audience. We'll talk to you. Have a good weekend. Bye-bye.
Great questions today.
Yeah, great questions for sure. See y'all.